We've all been there. You walk into a high-end specialty store, maybe you're looking at a single malt Scotch or, I don't know, a
Yeah.
50-year-old vintage Bordeaux,
hmm
and the price tag is just, well, staggering. Our immediate instinct, probably fueled by decades of marketing, is, wow, if it's that expensive and that old, it must be vastly superior.
Right. But that instinct, it often leads us down a pretty expensive path, doesn't it?
That really does.
This deep dive is really for you, the learner, to kind of understand the reality behind that. Are we paying for genuinely superior flavor, actual chemical perfection?
Or are we just paying the logistical price, the cost of keeping a rare label safe
Right.
for, like, half a century?
Exactly. That's the core conflict we're digging into today.
We are pulling back the curtain on the complex chemistry that transforms new alcohol into
Huh.
something really sublime.
Mm-hmm.
And then looking at the economic reality that sends those prices just soaring.
Mm-hmm.
Our mission is to pinpoint exactly where that optimal flavor peak occurs and where the price curve just completely abandons flavor and, launches into the stratosphere.
And the crucial distinction, as our sources really emphasize, is that quality in aged beverages doesn't follow a straight upward line. It's not like older just keeps getting better indefinitely.
Okay.
It follows more of a bell curve. You hit a point of peak balance where all the complex factors just integrate perfectly.
The sweet spot.
The sweet spot, exactly. And then if you go too far, the flavor actually starts to degrade and decline.
But the pricing doesn't always reflect that downturn, does it?
Rarely. The price often keeps climbing.
So we're looking for that moment of mastery, right? That precise point of integration. It's not about maximum age. It's about maximum balance.
Perfectly put.
So let's start at the microscopic level. What actually defines this period of transformation? What's happening in there?
Okay, well, to appreciate that peak, you first have to appreciate the journey, I think. Aging is this profoundly complex chemical transformation. It develops flavors, aromas, textures that are frankly completely impossible to create immediately after fermentation or distillation. It fundamentally re-engineers the character of the drink.
And the most important ingredient in this re-engineering process, maybe surprisingly, isn't the alcohol itself, but oxygen.
Yes, but it has to be controlled oxygen.
Yeah.
Think of it like the liquid taking a very gentle breath over a long time.
A gentle breath. Okay.
We call it controlled oxidation. And it's absolutely essential for developing complexity and mellowing those often harsh, sharp alcoholic notes you find in really young spirits or wines.
Makes sense.
In a whiskey, for example, oxygen enters slowly through the porous oak barrel. This triggers reactions that create esters.
Estrus, okay.
Those are the compounds responsible for a lot of the lovely fruity and floral characteristics we like.
But that word controlled seems really key here. If the spirit or wine takes too big a breath, that's bad news, right? How does a barrel stop it just turning into, like, vinegar?
That's the danger zone. If oxygen gets in too quickly or too much, you get over-oxidation.
And that means...
The liquid becomes flat, stale, and yes, you can start developing unpleasant, sharp, volatile acidity, sometimes described as vinegar-like notes.
Yeah.
But there's a kind of built-in defense mechanism that some beverages have. Red wines, for instance, tend to have a high concentration of tannins.
Ah, tannins.
Right. They act as natural antioxidants, which makes red wines structurally more resistant to oxidation than, say, most white wines.
Okay, that brings us to tannins themselves.
Yeah.
Those compounds, especially in young red wine, that give you that dry, sort of puckering sensation in your mouth.
Exactly.
They start out harsh, but you're saying they're essential preservatives. So what's the goal when aging them?
The goal is something called tannin polymerization. Think of it like this. Individual tannin molecules, which are initially small and kind of reactive,
Yeah.
they start to bind together. They link up into much longer, more stable chains.
Like little building blocks clicking together.
Yeah. Sort of, yeah. And as these chains become heavier and larger, they eventually become too big to stay dissolved and they fall out of the solution entirely.
Wait, so if I'm following this,
Yeah.
those little bits of sediment, the kind of crunchy bits you sometimes find at the bottom of a really old wine bottle,
Yeah.
that's not a flaw. That's actually the physical proof that the wine successfully softened itself over time.
Precisely. That polymerization process is what softens the texture and mouthfeel of the wine. It mellows out that initial astringency,
Okay.
and that allows the more complex secondary flavors, which were kind of hiding behind the harsh tannins, to finally emerge and, really shine.
And those secondary flavors, the fruity, the floral, the complex notes, We really prize in great aged drinks.
Yeah.
Thanks to the next big stage, the one I find kind of magical,
Yeah.
esterification.
Yes, esterification.
Yeah.
This is where the chemical construction really creates flavor magic, as you put it.
How does that work?
It's one of the most productive reactions during aging. Basically, organic acids that are naturally present react with the alcohols to produce these vital compounds called esters. And these contribute all sorts of desirable characteristics: vanilla, honey, spice, fruit notes. It's a huge indicator of quality development.
And is this a minor tweak or a really significant change?
Yeah.
Like in terms of actual volume?
Oh, it's extremely significant. Take bourbon, for instance. There's a key ester called ethyl acetate. Sources show its level can jump dramatically.
Dramatically.
From about, say, 160 parts per million in a fresh distillate,
Sure.
right off the still,
Yeah.
up to maybe 500 parts per million after just 6 years in the barrel. That's a massive chemical change in concentration in a relatively short time.
Wow. Over 3 times as much. And none of this magic would happen without the container itself, right? The oak barrel. It's not just a passive holder.
Absolutely not. It's an active participant. The extraction process from the wood is vital. The charred oak imparts specific compounds directly into the liquid.
Like what kind of compounds?
Well, you get vanillin, which gives us that recognizable vanilla flavor we often find. You get furfuryls, which contribute caramel and toasted notes. Lignin compounds can offer smoky phenolics. And of course, the barrel contributes even more tannins for overall structure.
And I guess how much char, what kind of oak, whether the barrel's been used before, all that matters hugely.
Critically important, all those factors dramatically impact the final profile of the spirit or wine.
Okay, so that's the adding side of the equation. The barrel gives good stuff. But what I find genuinely amazing is that aging isn't just about adding complexity.
No.
It's also about taking away bad stuff, a subtractive process that removes genuinely unpleasant flaws.
It's astounding when you realize it, isn't it? The quality we often pay a premium for is as much about what the barrel takes away as what it adds.
Seriously.
Seriously. Aging removes many undesirable compounds that were present right after initial fermentation or distillation. For instance, in bourbon, there's dimethyl sulfide.
Okay, what's that?
It has this distinct, unpleasant, tinned tomato flavor.
Tinned tomatoes.
Right.
In bourbon.
Yep. But during aging, it's slowly oxidized into dimethyl sulfoxide, which is essentially flavorless. The barrel helps scrub it out.
Okay, aging removes the taste of tinned tomatoes. That alone is a win in my book. What other unappetizing flavors is the barrel quietly getting rid of?
All right, here's the wow fact that might change how you think about this whole process.
Lay it on me.
Aging significantly decreases the levels of a compound called thiomenthone.
Thiomenthone. Never heard of it.
Probably for the best. At high concentrations, thiomenthone has been described in serious flavor analysis as smelling, well, exactly like cat urine.
No! Cat urine. Are you serious?
I am absolutely serious.
Yeah.
As the concentration of thiomenthone decreases during proper barrel aging,
Please tell me something good happens.
something very good happens.
Yeah.
It allows pleasant notes like desirable berry characteristics to actually be revealed in the spirit. They were masked before.
That is incredible. Aging is literally transforming cat urine notes into berry notes.
In a manner of speaking, yes. That right there shows you the power of this chemical transformation over time.
Wow. Okay, that alone shows why we need this process to run its course, but also why we need it to stop at the right time to reach that chemical peak.
Which brings us right back to timing and that bell curve concept we mentioned earlier.
Right.
We've established a chemistry. Spirits and wines have an optimal drinking window where all these elements, the oxidation, the polymerization, the esterification, even the subtraction of bad stuff, reach their peak balance.
Before the decline sets in.
Before the decline sets in, exactly.
So if that peak exists, what does the decline look like? What happens to whiskeys that spend too long in the barrel? They cross the peak and start going downhill.
For whiskey, the enemy often becomes the oak itself. If it's in the barrel too long, the wood just starts to dominate everything.
How so?
You get overly woody flavors, bitterness, really strong, astringent notes that completely overwhelm the original character of the spirit you wanted to taste.
So it just tastes like wood juice.
Kind of, yeah. It loses its balance. For Scotch, that sweet spot where things are usually in harmony is generally considered to be around 10 to 18 years old.
And bourbon. You mentioned climate earlier.
Right. Bourbon often peaks earlier, perhaps more like 6 to 12 years. The generally warmer climate in places like Kentucky accelerates the extraction rates from the oak and also increases evaporation.
The famous angel's share.
The angel's share, exactly. More loss, Faster aging, generally speaking, so the peak arrives sooner.
Okay, so climate is a huge variable in finding that perfect peak moment.
Mhm.
What about for wine that goes past its prime? What does that decline look like?
Overaging wine leads to complete, irreversible oxidation. The wine is essentially, well, dead is the term often used.
Dead wine.
Yeah.
Sounds grim.
It is. It becomes flat. You might get notes of rusty metal or stale nuts, just very dull. And you see a dramatic color shift, too.
How does the color change?
Red wines turn sort of an unappetizing brick red or even brown. White wines darken significantly, moving towards amber or golden brown.
And I assume if the cork fails, that speeds everything up.
Oh, dramatically. A failing cork lets in too much oxygen too quickly, accelerating that whole degradation process.
We should probably be clear, though, right?
Mhm.
Some premium red wines, the really well-structured ones from top regions, can age for a very long time.
Absolutely. Some can definitely improve for, say, up to 30 years, sometimes even longer in exceptional cases. But for most red wines you buy,
Yeah.
they're optimally enjoyed somewhere between maybe 3 and 15 years.
And white wines, since they usually lack that heavy tannic structure.
Most white wines are generally best enjoyed pretty young, maybe within 2 to 3 years of the vintage date.
But there are exceptions there, too.
Definitely. It's crucial to know that high-acid varieties, think German Riesling, or some of the great dessert wines like Sauternes, they have incredible structural foundations.
Acid acts like tannins in reds.
In a way, yes.
Yeah.
That high acidity acts as their primary preservative, allowing them to age gracefully for decades, sometimes 30 years or even more. It's quite remarkable.
Okay, this brings us, I think, to the really practical part, the financial reality.
Hmm.
We've defined the chemical sweet spot. Let's use that 10 to 18 years for Scotch as a key example.
Mm-hmm.
Now we have to connect this taste curve, this quality curve, to the value proposition, because this is where, flavor physics meets market economics.
This is the pivot point for buyers, absolutely. For consumers out there seeking the optimal blend of measurable quality and, let's face it, sensible price.
Yeah. Value for money?
Our sources consistently show that the 10 to 18-year range for Scotch typically offers the best value proposition.
So if you stick to the younger end of that, say 10 to 12-year-olds.
You generally get reliable distillery character, good smoothness, decent complexity, all at a relatively modest price point. It's the excellent kind of everyday sipper category for quality Scotch.
Okay. But the real magic zone, the peak of that quality bell curve.
That often seems to land in the 15 to 18-year bracket. This level frequently offers a really notable step up in depth and flavor integration.
Integration meaning everything is married together perfectly.
Exactly. All those complex compounds have had time to harmonize beautifully, yet critically, bottles in this range remain vastly more affordable than the ultra-aged examples. It hits that value sweet spot.
But then, something happens after 18 years, doesn't it? The financial dynamic just changes completely.
It really does. Once you cross that threshold around 18 years or so, the price curve seems to stop listening to the quality curve and just goes, well, rogue.
Rogue is a good word. We see prices starting to rise sharply, often exponentially, right?
Yeah.
Especially between 18 and maybe 21 years and then beyond.
And here's the absolute core takeaway for you, the consumer. While those ultra-aged bottles, the 25, 30, 40-year-olds, might carry immense prestige and look amazing on a shelf, the actual flavor improvement beyond, say, 21 years is often marginal, sometimes subtle, sometimes maybe even non-existent, depending on the cask and spirit.
But the cost just skyrockets.
Astronomically.
So why? Why is a 25-year-old bottle maybe 5 times the price of an already excellent 18-year-old if the flavor improvement is negligible or even negative? It can't just be taste.
It's not about taste at that point. You're dealing with pure logistics, scarcity, and the economics of time.
Okay, break that down. What are the drivers?
Absolutely. We can point to about 4 main economic drivers. First, just the basic logistical cost. Storing barrels for decades takes up space, requires monitoring, insurance. It all adds up significantly over 20, 30, 40 years.
Makes sense. What's second?
Second is evaporation losses. That angel share we mentioned. It continues year after year. An older cask simply yields fewer and fewer bottles when it's finally ready.
So each remaining bottle has to carry more of the initial cost.
Precisely. The yield cost per bottle goes way up. Third, you have just inherent rarity.
Meaning?
Decades ago, producers simply didn't anticipate the huge global demand we see today for really old, well-aged whiskey. So the actual physical supply of those genuinely old barrels is extremely limited.
Basic supply and demand driving a massive scarcity premium.
You got it. And finally, number 4, there's the time value of money.
Finance 101.
Pretty much. The capital that's tied up in that inventory sitting in a warehouse for maybe 50 years, that capital could have been invested elsewhere. Distilleries need to be compensated for that decades-long wait. They require a financial premium to cover those lost investment opportunities.
Right. So putting it all together, the overall synthesis for the informed consumer is basically this. Once you get much past that 21-year mark, maybe even 18 for some,
Mm-hmm.
rarity and collectability and all those economic factors utterly overtake good value in terms
Yeah.
of taste. You are paying for time, for logistics, for scarcity.
Not necessarily for a product that actually tastes better than its already excellent and much cheaper 18-year-old counterpart.
Okay, so let's try and summarize the big takeaways from this deep dive.
Let's do it. First, I'd say remember the chemical bell curve. Flavor and measurable quality in aged beverages tend to hit an optimal peak, like that rough 10 to 18-year window for Scotch, before potentially declining into overly oaked or oxidized profiles if left too long.
Older isn't automatically better on the chemistry side.
Got it.
Takeaway 2.
Second, remember the economic exponential curve. Price, especially after that optimal flavor window, often follows a curve driven almost entirely by scarcity, long-term storage costs, and the angel share losses.
So the price skyrockets for reasons largely unrelated to further taste improvement.
That's the crux of it.
The goal then, when you're buying or just appreciating these complex liquids, isn't about proving that older is automatically better. It's more about what? Finding that sweet spot.
Finding that precise, balanced moment, the point where the initial harsh elements have mellowed out, the complex, desirable flavors have fully developed, but the spirits or wine's original character still remains vibrant and everything is perfectly integrated.
It's an art of chemical timing, really.
It truly is, balancing all those factors.
Okay, so if the optimal flavor for, say, Scotch often peaks around 18 years old, and it's really only economics driving the huge price of a 30-year-old bottle. Well, it raises a pretty interesting question for you, the learner, to think about after this. What other everyday consumer goods out there are we maybe buying based mostly on the perceived scarcity of time or rarity or just a high price tag, rather than their true measurable peak quality?